So this section is 2.6 called linear inequalities. And a linear inequality results whenever the equal sign in a linear equation is replaced with any of the symbols like less than or equal to, greater than or greater than or equal to. So let's take a look at those particular symbols just so that we have this in our notes. So for a linear inequality, we have inequalities. And we're talking about the symbols. So the symbols are such as this symbol here. This is called less than. And we could have an example like 4 is less than 5, which is true. And we're only considering true statements in inequalities. So 4 is less than 5, so it's true. Another symbol we would be looking at is the less than or equal to. So less than or equal to. Okay? And so the less than or equal to could be examples like 5 is less than or equal to 5. This is true because 5 can equal 5. Because remember, it's got the word or in it. So either one, we're looking for a true statement. So this is true. And so we could also do is say negative 3 is less than negative 1, which is also true. So that's what less than or equal to is. And you have to know these symbols by heart as you're doing your work. Another symbol is going the other direction. This means greater than. And an example could be like negative 1 is greater than negative 10. That's a true statement. Negative 1 is greater than negative 10. Okay? Or we could have greater than or equal to. So greater than or equal to. And so another example could be something like negative 3 is greater than or equal to negative 3. Or negative 3 is greater than or equal to negative 7. Okay, these are all true statements. And that's what we need to make sure everybody knows is these symbols, because we put them into the equation and take out the equal sign that we see all the time. Okay, so let's make sure we have that in our notes. So we could look at some examples of particular equations, like let's say we have x less than 2. This is an inequality. And if we were trying to solve for this, well, it's all the numbers less than 2. It can't equal 2, but everything up to 2 is what this statement is saying. And so to write all the numbers would be really time consuming. You never get done because there's infinite numbers that are less than 2. And so we typically like to do a graph for that. So if I graph this x less than 2, it's basically a straight number line. Okay, so here's my number line. This direction is negative, this direction is positive, and then I'll put 0 in the center. Okay, and so now I'm going to put where 2 is. This is my initial start point. So here's 1 and here's 2. So here's 2. Okay, and so I see it's all the values in this direction. Well, I don't want to include the 2. So to do that, we do this parentheses, and we do a parentheses right at 2. And so that's telling the person who's reading the graph that, oh, this does not include 2, but everything behind the 2. And then we can put a line going in this direction. And so that's telling the person, oh, it's all the solutions here that make this inequality true. And so that's what we do. So we do parentheses when we don't have an equal sign in the inequality, but we do brackets when we do include the equal sign. So let's say we're doing x less than or equal to -1. Again, we create a number line, okay, and I have a 0 set here, and so I mark where the initial number is, which is -1, and it's all the numbers less than -1, so I'm going to make a bracket, right, going in that direction, and put my line going that way. So it's basically saying everything starts at -1 and everything less than -1 is the solution to this particular equation. And so that makes it really nice to show people so that you don't have to write all the numbers, which is not possible. We do that later in interval notation, which I'll do in a different video. So let's take a look at another example. Let's say you have an inequality that is not in that simple form. Let's say you have 3x minus 4, right? And that's less than, well, let's do greater than 10, even though the book says less than. All right, so we have this inequality. It looks just like a regular equation, but we don't want to have to keep guessing what numbers make this inequality true. So we'll go and solve it just like we do a regular equation. So I'll add 4 to both sides. And so now I get 3x greater than 14. And then I'll divide by 3. And so then I get x greater than 14 thirds. Or if I want to get it into a decimal form, 3 goes into 14 at least 4 and 2/3 times. So that gives me an idea of where it is on my number line. So now I create my number line. Right? This is the negative direction. This is the positive. I'll put 0 where it belongs. And then I'll mark where 4 is. 1, 2, 3, 4. And then here's 5. And 4 and 2/3 is slightly past half. So somewhere around here. Okay, and since x has got to be greater than 14/3, it's got to be a parentheses going in that direction, and I make an arrow. And so that shows me the solution to this particular inequality. And so that gives you the idea of how that is set up. Let's do one more, which has a negative for the variable. So let's say we have, I'm just going to make one up here. Let's say it is 4 minus 2x, and it's less than or equal to 8. Okay, so again, we'll minus 4 from both sides. We'll get the negative 2x less than or equal to 4. We'll divide by the negative 2. And so this cancels to 1. We get x is less than or equal to negative 2. And so we think we're great. But here's the problem. When we get a negative in our equation that's next to the variable, we literally have to switch it to the other direction. And the reason why is because we know that this statement here should be the same as the final statement. They're exactly the same solution. So that has to be true for both of them. So if I didn't switch, let's say I went ahead and thought this was my solution. Let's say, what's a number that would make this statement true? Well, in this case, negative 3. Negative 3 is less than negative 2. So if I put that up here, 4 minus 2 times negative 3 is less than 8. I get 4 plus 6 is less than 8. And 10 is less than 8. That's not true. That's false. And so I would have to switch it to make both of the inequalities the same. So in this case, I'd say x is 0. Because 0 is greater than negative 2. So if I put that into the original equation, I get 4 less than 8. It's true. And so this tells me I have to flip the inequality. So the rule is, whenever you see a negative next to the variable that's being multiplied or divided, then you have to flip the inequality to the other direction. And that's all you need to know. If you don't remember, then you can do this test that I just did to help you remember. But that's the real reason why we actually switch. Oops, and that's the end.